All right, here we go. Section 4.5. We've learned two ways so far to prove that triangles are congruent to each other, haven't we? We just talked about this. We went over homework, right? We just talked about it. So what was the first way we learned how to prove triangles congruent? Side, side, side. Okay. Then the second way was what? Side, angle, side. Okay, these were both postulates, weren't they? What's it mean to be a postulate? We just accept it, right? Without having to do what? Without having to prove it, okay? So we don't have to prove these things. We just accept that it's true, all right? I mean, you could do some experiments with it. You could, measure things out and all that kind of stuff, and you would find out that these are true. They're absolutely true, all right? But they really can't be proven. Here's another one we're going to do. We're going to learn two more today, all right? But here's another postulate. We had side, 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 angle, side. What we're going to learn today is one that's called angle, side, angle. And so let's talk about what that means. It's very similar, okay, to what we've been doing. So it shouldn't take too long. It shouldn't take a whole lot of explanation. But I do want to point out a couple things about this. Good. John, say it. Say it out loud. The side. That's right. The side has to be between the two angles. So let's mark this ABC, and let's go XYZ on this. All right. Watch this. Everybody paying attention? Let's watch. And you should be writing this as well. So here's my two triangles. What if they told me that angle A was equal to angle X? Okay. Now, they just told me that, so I believe them. All right. And they also told me that this side was equal to this side. And they also told me that this angle was equal to this angle. Okay. They did. All right. So let's take a look. Now, according to this postulate, remember, all three of these are postulates. We just accept that without fact. Okay. If I have this situation right here, Freddie, get your head up, please. Freddie, get your head up, please. Take your hood off. Thank you. Sorry. Just got to follow rules, that's all. Take your hood off. All the way up. Thank you. All right, so I've got two triangles right here. If I know this, if I got one set of angles equal, I got a second set, and I have the side that's in between, or the included side. All right, we call that the included side. If I know that's true, what can I say about those two triangles then? They're congruent. So I could say with this information right here, I could say that triangle ABC is congruent to triangle. Now, it has to be in a certain order. If I go ABC, what's this? XYZ. All right. So it has to be in that order. So those are congruent. Now, if I asked you why, what would you tell me? Because they're congruent? That's a reason you want to use? No, it's not CPCTC. Again, that proves my point, what we talked about earlier. Don't just throw that CPCTC all around anywhere you want. To prove triangles congruent, these are the only ways we know so far to prove triangles congruent. It's not side, side, side. It's not side, angle, side, because I only know one pair of sides. It's what? It's angle, side, angle. Okay, there's an angle, there's a side, there's an angle. Now watch. Okay. Now let's take a look. I want you to really concentrate on this. This takes a little bit of thought. So let's pay attention. Let's concentrate. What? You're fine. So let's take a look at these two triangles right here. Let's think of something that we learned a little earlier. Watch this. Since I know two angles equal two angles here. Freddie. And I said no. If I have two angles equal to two angles, we had a theorem that we talked about some time ago, maybe a week ago, maybe less than that, I'm not sure. What must be true about that third angle? If I have two angles equaling to two angles, remember that? Then the other two angles, or the other pair of angles right here have to be equal as well, don't they? What do we name that? It was a theorem. We had a name for it. Third angle theorem. Very good. Okay, it's the third angle theorem. So now let's watch this. This is something that didn't happen on the other ones, because on the other ones, I didn't know two angles, did I? I didn't know any angles equal here. I only knew one pair of angles equal here. So this is the first time where we've had two angles actually equal to each other. So let's watch this. So now I have actually three angles, don't I? Actually, you know what I should have done? Let's get back to that just in a second. All right, sorry, I got a little ahead of myself. Let's do this. What if I just had two angles equal to two angles? Would these triangles be congruent right now? No, they wouldn't. What if I did this? What if I said that this side and this side were equal? Are they congruent because of angle, side, angle now? Well, I got two angles and a side. Why aren't they? It's not in between. That's right. Now watch. Catch this. This side and this side right here are not between my two angles. But let's go back to what we did earlier. We do know, though, that this angle is equal to this angle, don't we? Because of the third angle theorem. Now, let's take a look. Now, knowing that this angle is equal to this angle, and this side is equal to this side, now how do you think I could say those two triangles are congruent to each other? I could now use angle, side, angle again, couldn't I? All right? Everybody see that? Even though before I knew those yellow angles were equal to each other, I couldn't have said that those triangles were congruent. All right? So, but now that I know by the third angle theorem that this angle and this angle are equal to each other, and this side and this side, and this angle, now I could say angle, side, angle, couldn't I? But instead of going through that, instead of looking at the third angles, instead of saying that those third angles are equal to each other, watch this. We know these triangles are congruent to each other, but look what I have. I have angle, and I have side. Everybody see that? The side now is not in between there. So that's actually a fourth way to prove that triangles are congruent. Let me scooch this down a little bit. Put it back up here. So look. So you know, if I have two angles and a non-included side, that side doesn't have to be in between here. These are not congruent because of angle, side, angle, are they? Okay? But now we just learned a new way. And we came up with it kind of on our own. We actually did a little, that's kind of like a little proof. So this is now not a postulate. This is now a, what do you think? It's not a postulate, but it's a, no, it's a theorem. It's a theorem, okay? And this theorem is angle, side. And that's actually a theorem. Okay? So what's different about this? You look at this, you're like, well, what's the difference? Who cares? This is angle, side, angle. This still has two angles and a side. This has two angles and a side. What's the big difference between the two? Well, the big difference is this side is where? The first one, number 3. It's in between the two angles. It's the included angle, isn't it? I'm sorry, it's the included side. What about this one right here? Look at that side. It's outside the other two angles, isn't it? Okay? It's not in between the two angles. So we would call this what? Angle, side. Some people said, well, can you call it side, angle, angle? Well, I guess you could. All right, but we don't. All right? We just call it angle, side. That's what we usually call it. Somebody asked me in the other class, do we have an angle, side, side? Okay, you caught it. Okay? No, we don't. And it's not because of what you're thinking. All right? We don't have an angle, side, side because it makes a word we're not supposed to say. That doesn't. That's not why we have it. We don't have an angle, side, side. It just doesn't work. All right? Now watch. Okay, get it out. So we don't have an angle, side, side. Some people would say this just so we don't have to write it. Okay, we'll write it backwards, right? So, but is there a side, angle theorem? There's not. Okay. Now we don't have time right now. We only have a couple minutes left. We could show you why it's not true. Just because you have two sides and a non-included angle does not mean that the triangles have to be congruent to each other. And it's not just because it makes a word we're not supposed to say. That's not the reason. All right. It just doesn't work. All right. It just doesn't work. So there is no side, angle or angle, side. Everybody understand that? Okay, so that does not exist. Don't use that as a reason for your triangles being congruent to each other because it doesn't work. So if I had two sides, and I'm not going to spend much time on this, but I'll just show you this part. Watch. If I had two sides right here and a non-included angle, does it mean that these triangles are equal to each other or congruent to each other? No, it doesn't. Okay, and we just don't have time to go through it, but just believe me, it does not work. There is no side angle. All right, that's pretty much it. So I'm going to give you a worksheet, and it's going to be section 4.5 worksheet. You're going to do all the problems on it. Okay, you're going to do every problem. It's a front and a back. All right, so you're going to do the worksheet, and it's kind of the stuff that we did earlier. where they give you a picture, they give you a given and prove. You just have to mark your picture and tell me why those triangles are congruent to each other. That's all you got to do. So that is due tomorrow.